Given a vector in component form, find the magnitude and direction in the interval 0 to 2 pi. So let's look at the vector u, which is 2, negative 4. So I drew it on the coordinate plane. So when we talk about the magnitude of a vector, it has a particular way that we can write it. So this double line with the vector inside sort of looks like an absolute value thing with double lines, means the magnitude of a vector. So that's x squared plus y squared square root of that. So basically it's Pythagorean theorem. So the magnitude of the vector is like the hypotenuse. This is one way of looking at this, because that's what this formula looks like. Alright, so the magnitude of the vector. So we've got 2 squared plus negative 4 squared. Of course the negative doesn't do anything. And then square root of that. So that's the square root of 20, which is 2 times the square root of 5. So that would be the magnitude of the vector. Now we also need the direction of the vector. So the direction of the vector is in standard position. So with your initial side lying on the positive x-axis, standard position would be, this would be your theta, your direction. Alright, so we can figure that out by taking the inverse tangent of the x side, the y side over the x side. So that'll give us this angle here, which is our reference angle. And then depending on the quadrant, we'll take it from there. So first let's figure out theta bar. That's your reference angle with the x-axis. So that's equal to the inverse tangent of y over x, where y is, let's just use all positives here, and then when we get our inverse tangent value, then we'll think about which quadrant we're in. So 4 over 2, so that's just 2. Alright, so in the calculator, I got 1.1071, and these are radians. So I'm in the 4th quadrant, so that means the angle in standard position would be 2 pi minus theta bar. So you're going to use your 2 pi button in there to get as exact as possible in the calculator. And you'll get a direction of 5.176 radians. Now let's see if that makes sense. So for in radians, here's 0, here's pi, which is roughly 3.14 radians, and then half of that would be roughly 1.57, and then you've got 3 pi over 2 radians, which is roughly 4.7, and then 2 pi over here, full circle would be 6.28. So if we've got 5.176 radians, that does fall in the 4th quadrant. So now we're done with that. We've got a magnitude of 2 square roots of 5 in a direction of 5.176 radians. So let's try another one. Let's try B. So I drew negative 3, negative 2. And now we're going to find the magnitude first. So that's the magnitude of V. So that's negative 3 squared plus negative 2 squared. Square root of that. So that's 13. Square root of 13. Alright, so now let's find the reference angle. So I'm going to draw my right triangle. Okay, so I've got 3 and I've got 2. I'm just going to read it off of there. So I've got theta bar, which is there, is the inverse tangent of 2 over 3, which is 0.5880 radians. And we want, in standard position, the angle theta. So that would be pi plus 0.5880 radians, which is 3.7296 radians. All right, so then we look and see whether that makes sense. So 3.14 here, 4.7 here, and our number is in between and in the third quadrant, so that makes sense.